Namaste everyone. Welcome to the fourth lecture of polynomials. This is Rajesh, and in this lecture we will see factor theorem, factorization of polynomials, and we will solve exercise 2.4. So let us start with factor theorem. If px is a polynomial of degree n greater than 1 and a is any real number, then x minus a is a factor of px if p of a is 0 and p of a is 0 if x minus a is factor of px. This is factor theorem. Now, in the last lecture we have seen remainder theorem. Remainder theorem indicates that if I divide a polynomial with a linear polynomial like x minus a, then p of a gives me remainder. Now, if I divide by x minus a and my remainder is 0, so then it indicates that x minus a is the factor of px, right? So here the statement is that x minus a is factor of px if p of a is 0. And if p of a is 0, it indicates that x minus a is a factor of px. So this is a factor theorem. Now let us first see few problems based on this factor theorem. So we move to exercise 2.4. We will see the first problem. Here we have to determine which of the following polynomial has x plus 1 a factor. Now see the first question. The polynomial is x cube plus x square plus x plus 1. And I have to check whether x plus 1 is a factor. So what we do? Let us first consider px as the given polynomial x cube plus x square plus x plus 1. Now I have to check whether x plus 1 is a factor. So what I will do? I will first find out 0 of this x plus 1, which gives me value as minus 1. So I will find p of minus 1. Now x plus 1 is a factor of px if p of minus 1 is 0. This is our factor theorem. So let us find p of minus 1. Now p of minus 1 cube, how we find? Px is x cube plus x square plus x plus 1. So p of minus 1, in place of x we will replace minus 1. So it will become minus 1 cube plus minus 1 square plus minus 1 plus 1. Now this minus 1 cube is minus 1, this is plus 1. So minus 1 plus 1 0, then minus 1 plus 1 0. So I will get result as 0. Now as p of minus 1 is 0, it indicates that x plus 1 is a factor. So we will say that by factor theorem x plus 1 is a factor of x cube plus x square plus x plus 1. Yes? Okay. So let us move to the next question. The second question is x power 4 plus x cube plus x square plus x plus 1. Here again we will find the 0 of x plus 1. Now the 0 of x plus 1 is minus 1. Again we will find p of minus 1. Now here p of minus 1 is 1. This is not equal to 0. So we will say that x plus 1 is not a factor of x power 4 plus x cube plus x square plus x plus 1. In the same line we will solve question number 3. Here again we will find p of minus 1. P of minus 1 is 1, which is not equal to 0. So by factor theorem x plus 1 is not a factor of x power 4 plus 3x cube plus 3x square plus x plus 1. And let us see the final question. X cube minus x square minus in bracket 2 plus root 2 times x plus root 2. So here again we will find p of minus 1 because we have to check x plus 1 is a factor or not. So we find p of minus 1. This gives me answer as 2 root 2. This is not equal to 0. So I will say that by factor theorem x plus 1 is not a factor of x cube minus x square minus 2 plus root 2 times x plus root 2. So this is how we are using the factor theorem. This is one type of problem where we are utilizing the factor theorem. Now let us see the second type of problem. Here I have given two polynomials px and gx. Now here we have to check whether this gx is a factor of px. So what we will do? We will first find the 0 of this second polynomial, which is gx. So here we will substitute gx is equals to 0. That gives me x plus 1 is equals to 0. From that we have x is equals to minus 1. Now by factor theorem I will say that gx is a factor of px if p of minus 1 is 0. So let us find p of minus 1. Now p of minus 1, it gives me answer as 0. So I will say that by factor theorem gx is a factor of px. Now let us see the second question of this question 2. Here px is x cube plus 3x square plus 3x plus 1 and gx is x plus 2. We have to check whether gx is a factor of px. So what we will do? We will we will find 0 of this gx, which gives me value of x as minus 2, and here we are going to find p of minus 2. Now if p of minus 2 is 0, I will say that gx is a factor, and if p of minus 2 is not equal to 0, I will say that gx is not a factor. So this problem you can try yourself. The third question, here gx is x minus 3. So if I find the 0 of this gx, it gives me x is equals to 3. So I will check p of 3, and if the value of p of 3 is 0, I will say that gx is factor, and if it is not equal to 0, I will say that gx is not a factor of px. Now let us move to third question. Find the value of k if x minus 1 is a factor of px in each of the following cases. Now here in this question, it is already given me that x minus 1 is a factor, and there is one unknown k in p of x which I have to find out. So as it is given that x minus 1 is a factor of px, what we will say that? We can say that by factor theorem p of 1 is 0. So let us find p of 1. Now p of 1 is 1 square plus 1 plus k. Now I will equate this with 0 because p of 1 is 0, and this gives me 2 plus k is equals to 0. So this gives me the value of k as minus 2. See how we have find the value of k, right? Okay, let us see one more problem. We have to find the value of k if x minus 1 is a factor of px in the following case, where px is 2x square plus kx plus root 2. Now let us find p of 1 and equate it with 0, because x minus 1 is a factor. So by factor theorem p of 1 will be equals to 0. So what we are getting? 2 plus k plus root 2 is equals to 0. This gives me k is equals to, this 2 and root 2 will move on the right hand side, or they transform on right hand side, and the plus sign will become minus sign. So I have the value of k as minus 2 minus root 2. Let us see this third question also. Here p of x is kx square minus root 2x plus 1, and x minus 1 is the factor of px. So by factor theorem we will say that p of 1 is 0. Therefore k into 1 square minus root 2 into 1 plus 1 equal to 0. This gives me the value of k as root 2 minus 1. Now let us move to the fourth question. Find the value of k if x minus 1 is a factor of px in each of the following cases. Now px is kx square minus 3x plus k. So let us see, x minus 1 is a factor of px. Therefore by factor theorem we will say that p of 1 is equals to 0. So k into 1 square minus 3 into 1 plus k is equals to 0. On simplification, I have the value of k as 3 by 2. So this is how we are using the factor theorem. Now let us see the factorization of quadratic polynomial by splitting the middle term method. Let us first consider a quadratic polynomial as ax square plus bx plus c. Now here we need to find two numbers, say p and q, whose sum is equals to b, that is this middle term, and whose product is equal to a into c. As we are finding two terms whose sum is equals to b, this method is called splitting the middle term method. This is middle term, and we are splitting this middle term b in two parts whose sum is b and whose product is a into c. So ax square plus bx plus c I can write as ax square plus bx plus qx plus c, and then I will take common terms. Let us see with an example how we do that. So we will take one example, 12x square minus 7x plus 1. Now here what we will do, we will find 12 into 1, that is 12, and we will split in two parts such that and their addition is minus 7. Now the product is 12, that means both the factors either should be positive or negative, but as I need sum as negative, both the factors will be negative. So 12 I can split as 6 into 2, I can split 12 into 1, I can split 4 into 3. So I have to check which two factors give me addition as minus 7. So minus 4 and minus 3, their product is 12 and their addition will give me minus 7. So I will write this 12x square minus 7x plus 1 as 12x square minus 4x minus 3x plus 1. Now from this 12x square minus 4x, we can take 4x common. So after taking 4x common, I have 3x minus 1. Now from this second part, I will take something common which gives me 3x minus 1 in the second part also. So let us take minus 1 common. So I have now 3x minus 1 as a common factor in both the parts. So again I will take this 3x minus 1 as common, and I get 3x minus 1 into 4x minus 1. How this 4x minus 1 is coming? So 4x is remaining in this part and minus 1 is remaining in this part. So in other part I have 4x minus 1. This is how we are factorizing the quadratic polynomial by splitting the middle term method. Now we will going to see the problems based on factorization of quadratic polynomial by splitting the middle term method in the next lecture. Thank you for now.